Notifications look simple until delivery, retries, preferences, and scale enter the room. When I think about notification system, I start with the real job. Product events such as order updates, security alerts, password resets, and marketing or lifecycle messages. Before we pick components, be clear about the workload. This design has to handle email, SMS, push, and in-app notifications, plus preferences, templates, queues, retries, rate limits, delivery tracking, and idempotency, not just a clean demo request. The first diagram usually looks fine because it only tells the happy path story. For this topic, that naive version is usually the application sends notifications directly inside the request path and assumes every provider responds cleanly. I still start simple on purpose. The smallest version that can work here is the application sends notifications directly inside the request path and assumes every provider responds cleanly. That gives the team a baseline before complexity earns its place. Next, I walk one normal request or event through the simple design. That is where the useful questions start, because the path reveals what each component actually owns. The problem is not that the simple version is wrong. The problem is that it ignores what production will demand next. Provider outages, rate limits, and retries quickly turn direct send logic into a reliability problem. The first production pressure usually shows up here. Provider outages, rate limits, and retries quickly turn direct send logic into a reliability problem. That is the moment when a pleasant diagram turns into an engineering decision. Then operations gets involved. If the design cannot be observed, rolled out, and recovered safely, the system is already too expensive to own. In this topic that pain looks like without idempotency and preference rules, you duplicate messages or spam the wrong users. And then comes the part junior diagrams almost always skip. Operational visibility is weak unless you can inspect queue depth, template versions, and delivery outcomes. That is where production-grade thinking separates itself from feature demo thinking. So the better design adds only what solves a real problem. For this topic, that better shape is an event-driven notification service with user preference checks, templates, queues, workers, provider adapters, delivery tracking, and retry controls. This is what you gain from the stronger design. You decouple delivery from the request path and gain control over preferences, retries, and provider behavior. Those gains are why the extra complexity is sometimes worth it. But there is always a bill to pay. The cost of the stronger design is you now own asynchronous flow, deduplication, monitoring, and more moving parts than a direct send ever showed. The trade-off is the real system design conversation. Now I challenge the design with a failure question. Ask what happens when one provider is down, one event is published twice, or one customer has opted out on one channel but not another. If the diagram cannot answer that honestly, it is not ready. So the final architecture story is simple. Trace an event into template selection, preference filtering, queuing, worker delivery, retry handling, and final delivery status. That is the version I would be comfortable defending in a serious review. If you remember one thing, make it this. Viewers understand how to build a reliable notification system that does not spam users or collapse under load. Good system design is a judgment loop, not a memorized answer key.